Extreme weather in the northern hemisphere, such as the Pakistani floods and the Russian heatwave in 2010, affect millions. Since the turn of the century, the number of such extremes has greatly increased. Part of this increase can be explained by simple thermodynamic arguments. If the world gets warmer, then more extreme rainfall and heat waves are to be expected. However, the magnitude and duration of some heat waves and floods that we have seen in recent summers are disproportionate, and this puzzled us. Vladimir Petukov then made a surprising observation when searching the atmosphere for recent changes in circulation patterns. He saw quasi-stationary synoptic Rossby waves with high amplitude during these extreme events that persisted for weeks. Let me explain. Rossby waves are giant meanders in high-altitude winds in the mid-latitudes. When the winds in the Rossby wave swing up, they carry warm air from the tropics to the north, and when they swing down, they carry cold air from the Arctic to the south. Some Rossby waves are especially influential on our weather, because they create the high and low pressure areas on the ground, as seen on weather maps. Such Rossby waves have a specific horizontal length scale of around 1,000 kilometers and are called synoptic waves. Their wave number is about 6 to 8, meaning that 6 to 8 wave cycles fit around the globe. Normally, these waves move eastward, which means that weather systems move too. Sometimes, however, that eastward movement slows down or even freezes. In this case, high and low pressure areas persist over specific regions for longer than normal. That leads to extreme weather events. Rossby waves can be decomposed into freely traveling waves and forced waves. Freely traveling synoptic waves normally move quickly. Consequently, their stationary components are small. Free waves would exist even if our planet had no surface structure. They form purely due to the instability of the atmosphere. The second component, on the other hand, is forced into its shape by high mountain ranges and temperature differences between oceans and continents. They are inherently mostly stationary and their synoptic components are weak. Under normal conditions, synoptic waves lose energy toward the poles and the equator. Under specific conditions, however, the averaged west to east wind forms a confining channel called a waveguide. The waveguide stops this energy loss. When the wave is trapped, the forced wave can resonate with the stationary components of the free wave. This greatly magnifies the amplitude, only if they have the same wave number, of course. This is called wave resonance. As I said before, high-amplitude quasi-stationary Rossby waves cause extreme surface weather. So this is an important mechanism, and we have seen it more often in recent summers. The Pakistani flood and the Russian heat waves, for instance, were caused by the same wave. The resonance mechanism shows how delicate the interlinkages are between the components in the Earth system and how little changes in the dynamics can have big impacts on extreme weather and the society.